So I think we'll start now. I hope every one of you got the info that we are not doing the presentation that was originally scheduled for today. The model interpretability presentation from Charrington. We had to reschedule this, so this is going to be on the December meetup. And this time we decided to make a special where we want to talk about machine learning tools and frameworks. So Christian and I, we have some stuff to show today. And also, if there is someone in the audience who wants to show something, please just unmute yourself. You can really just, or you can just mention something that we can maybe discuss about, or yeah, if you have something prepared, some code maybe, or something you want to show, then you can just unmute yourself and jump in. Okay, so first things first. We'll do that like the last times. We'll have like 15 minutes for community discussion. Maybe some people want to discuss some stuff about the Fast.AI courses. And then we'll, the rest of the meetup, about 45 minutes, we are going to talk about the machine learning tools and frameworks. So yeah, let's go. Okay, yeah, the next meetup in December, just like I told you, she's presenting the Anchors paper, which is the predecessor of the Line paper that some of you may know. The Anchors paper, I don't know when it came out, it's pretty new, I think. And so she will generally talk a little bit about model interpretability and then specifically show you this Anchors paper, which gives you a way to find explanations for why a model made a certain prediction in a model agnostic way. And that's going to be interesting, I'm sure. And if you yourself want to present a paper, please go over to dplyr.com meetup if you are not registered yet. And if you are registered, you can just reach out to me at Kai on the Slack channel. And you don't have to be an expert to present a paper. Actually, when I presented capsule networks on the first meetup, that was the first time I read something about that. So please don't be shy. You can just take out a paper, read it, try to understand it, and then make a little presentation about it. Yeah, I'm pretty sure that most of you are familiar with the study groups that Sam is hosting on TWiML Fast.AI, of the Fast.AI courses, and Christian is actually one of the hosters of the machine learning course. I think, how far are you in the course now, Christian?
To be honest, I missed the last one, but I think we are lesson 5 or so.
Lesson 6.
6 now.
We are, yeah, we done the 5 lessons. We are in lesson 6.
Yeah.
Okay. Yeah.
And end of the random forest, basically.
Yeah. Okay. So I'm sure that there's going to be a new course, so that when other people come in and want to do the course again or do a new run of the course, then this is going to be announced on Slack. Yeah, this time really we don't have, since there is no speaker really, we don't have to wait for questions. So just interrupt if you have a question and want to ask something. I think that's the best. Okay, community discussion. So do you have anything you want to discuss with the group? Maybe something about the Fast.AI courses, or anything you heard about, or on some of Sam's shows?
Yeah, so there was an interesting, I don't know if anyone listened to the talk from the Endava series by the young lady, I can't remember it specifically, but she actually was quite negative on the explainability technology where it kind of smooths out the neural network so that you can create a visual meaning from the pictures. So it would be interesting to introduce that into the paper as well. I can find it for you. You kind of caught me on the hop here.
Okay.
Yeah. So I'll post that in the chat session a bit later on, but that might be an interesting one to bring up when we talk about the explainability piece and the anchors, specifically the follow-on from the anchors, which is what she talks about.
Interesting. And what did she say? I think I remember the show. It was I don't remember the name.
Yeah. So essentially, she was saying that if you diffuse or smooth out using Gaussian filters, the values in neural networks, you're essentially throwing away critical information.
Okay.
So when you smooth things out, it does allow human beings to see what is there and essentially interpret it and gain some intuition about it, which is very valuable. Yeah. But her point was that that's an arbitrary association. Anyway, I don't want to get too far down that.
Yeah. Okay. Yeah. Interesting. Anything else? Anyone? Who of you in this meetup is also participating the Fast.AI? I think, what is it? V3 course? Yeah, V3, right?
I am participating in the V3 course.
Oh, awesome. Where's the chat? Oh, there it is.
I was just curious, has anyone done the previous one and this one? And can they give us like a 2-second breakdown as to the differences and whether it's really a leap or whether it's just a...
Yeah, so I have done the previous one on MOOC. So, and I'm doing this one. And I think like, obviously things have changed in the sense that the order has changed. I remember the SGD part of it being covered in like maybe the 5th lecture or something. Now this is in the 2nd lecture. Also, he started off with cats and dogs, like a 2-class classification on his first lecture last time round. This time it's more like a multi-class classification in the first lecture itself. And obviously the 1-cycle policy has been made default, it seems. So those are changes I've noticed as of now. And I think a bit of the plot was lost in the 2nd lecture. He wanted to cover a little more, but like didn't go through because of some of like the technical delays.
Yeah, it definitely changed. It definitely changed the order of things. Yeah. But I mean, it's maybe, so this was the 2nd lesson. So we'll see how it's going to continue, right? Okay.
Oops.
If no one wants to discuss anything.
Yeah. Another thing which is there on my mind, I'm participating in this call for the first time, this conference, but like I work as work in the data science team here based out of Mumbai, India. A discussion one of these days around like the Bayesian error and the human error, because in our scenario, we have this machine learning model where we are trying to replicate humans, but we do think that the human error rate is not exactly great. So like, is there a way like in which we can discuss about how to model for the Bayesian error rather than the human error rates? That will be great, because like my understanding in this is fairly limited.
So what are you trying to replicate?
So I work for this fantasy sports company, okay, and where we are putting up contests, and the contest, we call this a contest generation engine, where basis the demand and supply and the overall state of the system, liquidity in the system, we are able to generate contests which will cater to all people. And this process was like completely manual for the last 3 or 4 years. But given that we are hosting more than 1 million contests every day now, we can't really have a manual system. So we have been able to replicate what humans were doing, because we are bang on with like what a human is expecting to be put up. and what we are putting up. But in case we want to get to that higher revenue, lesser losses kind of a model where it will be perfectly optimized, we don't really want to model for what the humans have done. For now, what we have done is like we have taken the historical data as to what humans have been doing for the last 4 years, and then tried to replicate it using using a model. Like any discussion around like how we can achieve more of a bias error, which is like which will probably be like an ideal scenario. That will be great.
Awesome. Sounds great. And are you using deep learning for now? Or?
Yes, actually for a part of it, we are using deep learning, but not for all of it. So for every match, we have to actually get to the revenue that will come through in this match. And for that, we needed some kind of an embedding for every team which plays the match. So for that, we have actually used Fast.AI to get the embeddings for every team. And that worked out particularly well for us like 3-4 months back.
Interesting. So you use the old library, Fast.AI library, not the brand new one? Right?
Not the brand new one, the Fast.AI version 0.7, which was there in the book. Yeah.
Interesting to see that this is used in production, right?
Yeah.
Yeah, but I think you're probably going to switch to the new one when it's, I don't know, do they will release now or? Yeah,
so I think they're going to release in the next 1 month. There's going to be some change. I'm keeping a close eye on that.
Yeah, one of the reasons I didn't jump in is when I first tried it, it was very, very glitchy and buggy. So I thought I'd give them some time to.
Yeah, and they're really making major changes.
Oh yeah, absolutely. I don't doubt it. Yeah. So.
Yeah. Bit crazy to follow the pips.
Yeah.
Yes. So just a couple of questions, Akid. What form is the user data captured in? Is it a markup tool, or is it a text stream, or is it just a bunch of structured data?
Structured data for sure. Like it's transactional data captured in a very, very structured way. Any transactional table.
Okay. Yeah. I see. Interesting. And it's not a time series or anything. It's just there's.
You can call it a time series, right? Because we have like for every timestamp, for every match that is going on, what user made what transaction. So.
Interesting. So you're trying to track sentiment? Is the goal of your machine learning to give you a sentiment analysis of a particular entry from someone? Some sort of. No, okay. That's what I'm trying to understand.
Yeah. So what we are exactly trying to do here is like say there's this fantasy website. Okay, lots of people playing, and what happens is like if say we put up contests worth $1 million. And every person has to put in, say, $10 each. And if we put too much of money on the table, then since the contest is guaranteed, even if we don't accumulate $1 million, we'll have to pay that money.
I see.
But if we put 2 less contests, then we are losing out on opportunity of making more revenue. So we have to make that balance according to the overall, like how many people are coming in, what is the state of the system? Because there is another big match going on, then this match might not get big traction. So there are a lot of states associated with the system.
Yeah, that's very interesting.
Do you have visibility in all matches? Like, can you see that one match is being very popular and could infer from that would detract from others? Is that information that you have?
It's there, like it's there in a dummy way, in the sense that we know for all the matches what happened, right? Say there's a match of A versus B, which has happened multiple times, and we know how much revenue came in, and revenue in a way shows us like how much popular the match was, and that is available over a period of 4 or 5 years. So we do have some visibility around like how popular the matches are.
Wow, that's very challenging. It's almost the weather problem where you use past records of weather to try and work out what the weather will be tomorrow based on a bunch of features. So have you identified a set of features in the data that you're using to train against? I assume that that would have to have happened.
Yes, we have. Like one of the most important things which we see is, again, one thing is like the popularity of the team. That's like super important for us, because the company is based out of India, so any India matches will have much higher popularity, things like that. Then the other thing which we saw was important was like time of the day, whether
Right, exactly.
if a match is happening at 3 AM, people will not tune in, people will not follow the match, they will not put in their money. That's super important. Some of the other interesting features are more related to the overall liquidity of our own system. Say there is one match that ends and a lot of money gets released into the system, is given back to the users. So after that, even if a small match is coming up, that will do much better. But if a small match completely overlaps with a big match, then it does horribly, because all the attention goes to the bigger match. So yeah, a bunch of other features, but these are like the super important ones.
Okay, very interesting. So I just saw that someone raised his hand. I actually don't know how I can, or what this means here in Zoom. So if you wanna say something, just unmute yourself and jump in.
So I can make a couple of comments to fill the void, but yeah, very interesting. So from what you've been telling me, this is a sentiment analysis problem where you're essentially trying to determine the sentiment coming into a particular competition. So essentially you have a series of these features that you've identified: big match going on, lots of money on the table, time of day, 30 others. You're feeding that into some sort of a model that's making a prediction of the sentiment around this particular competition, so that you can size the amount of prize money so that you make a profit, I guess is the point. Yeah, so techniques used for doing that tend to be LSTMs, RNNs, things like that. You might consider using some sort of RNN approach, I would suggest. But any comments, thoughts, anyone?
I was just trying to remember. I mean, that sounds similar to the scheduling that Dazen is doing when they basically decide which matches to cover. And then
Shocker. Give me the Shocker cleaning his teeth, please.
I'm trying to find the link. I'm not sure if there was a blog post about that.
Shakur, your webcam is switched on. Shakur, can you hear me?
No.
Okay. Hey, can you hear me? Your webcam is switched on.
He's just trolling. Just relax.
Yeah.
Okay, so let's go on.
He's on mute, so we are good now. I think he's on mute, so.
Yeah, he's on mute. Yeah, I muted him. Okay. So let's go on. Okay. This is what Christian and I am going to talk about today. So I have brought two topics, and the first topic I'm going to show you is dplyr. So does anyone know of you dplyr from R?
Yeah.
Okay. That's the first thing, and then I'm going to show you Docker, how I use Docker for data science environments. And it's probably not the way Docker was supposed to use, but I think it works pretty good to kind of use that for encapsulated environments, especially in data science. And Christian is going to show a little bit about plotting in Python. And I think I'm going to start with dplyr, and then we'll see if we have time to talk about this. This is not, I don't have a presentation for this, but this is what I recently found very interesting. So let me start with dplyr. So dplyr Yeah, dplyr is actually an R package created by Hadley Wickham, and he's also famous for the tidyverse. Maybe some of you know that the tidyverse is a collection of R packages that are centered around working with data. It's not about building models and creating creating models, but it's all about working with data and all the hard work you have to do to bring your data ready for modeling. And he actually has some really good concepts how to work with data. So the tidyverse is a very high-level interface to how you work with data. dplyr is especially one of the packages that's built for manipulating and working with tabular data. And so in R, it's a DataFrame, or a more modern version is called Tibble. And that's probably what when you are working with Python, it's the pandas DataFrame. So it's all about tabular data. And the dplyr package is built around five basic verbs. And that is select. And select is used to select certain columns of data, so features in your database. And filter is the function which you use to select specific rows in your data set. And then the arrange function is obviously to bring rows in your data in a specific order you wanna have. And mutate is used to create new features from other features in your data sets, so feature engineering. And summarize is used to build aggregates of certain portions of your data you wanna have a look at. I will show some code details in a few minutes for that. And there are some variations of those verbs and some helper functions in the dplyr package to build what's called pipelines. And that's a core concept in dplyr which you can use, and that is piping. And piping itself is a really easy concept. So in R, when you want to select, let's say you want to select 3 columns of a data frame in R, you can use the select function like this. So you use select and then parse in as the first argument the data frame you want to select of, and then the name of the 3 columns you want to select. So in this case, you would select this 3 columns, Michael 1, 2, and 3, from my data frame 1 and parse it into my data frame 2. So if any one of you did not ever work with R, this is the equal sign in R. And piping is when you would do the same thing with piping, it would look like this. So this is the piping operator, and when you have my data frame 1 and the piping operator, then this argument in front of the piping operator is parsed into as first argument into the next function. So it's the same thing like this, completely the same. So if you ask yourself, what is the point about that? The cool thing is when you do it like that, you can build data pipelines by chaining those commands. So when you, for example, want to select these 3 columns from the data set, then you can pipe it into the next function, and you want to filter some rows. So you want to select some rows from the data frame with a specific rule that you can write here. And then you want to generate another new feature by dividing the first feature by the second feature. And then you want to build the summary of all of this by calculating the mean for each of the features. And that is the dplyr way of writing this data pipeline. And maybe for this pretty easy use case, it's not that obvious why this is good, but when you kind of try to read through this, you will see that this is a very verbose way of working with data. So you can easily read that without even knowing R. When you at least know how piping works. So you can see that my data frame is from my data frame 1, there is a selection of these columns, and then you filter out some rows, and then you create a new row by dividing those, and you summarize them, all of those features. And yeah, so that's how basically dplyr works. And I can show you a little code example. Yeah, so this is our studio. So I am going to have a look into data from Airbnb. And there is a site which scrapes the Airbnb site. And for a lot of big locations, like in this case, Berlin, you can scrape a lot of data, or you can get a lot of data from all the accommodations you can book via our Airbnb. And I downloaded this Airbnb data from the site for Berlin in this case. Let me read this in. So this in, convert it to a DataFrame or Tibble, and when we have a look at this, you can see that there are. Wait, I have to make this. Can you see the whole RStudio screen on your side? Awesome. Okay, so we have 96 features in this tabular data set and 22,251 accommodations we can look at. And as you can see, there are a lot of different features that are recorded. Response time of the host, for example, or the name of the host, and the name, summary, how much space you have in this location, the description of the location. So basically anything you could scrape from the site, where it is, the neighborhood where it is, and a lot of other different stuff. Okay, so let's say we want to rename some of the features inside of this data frame, then that's the dplyr way of doing that. So you take listings, this is what I just loaded here, and then you parse it into the select function. You select, in this case, 4 of the features, and then this resulting data frame with those 4 features is parsed into the next function, which is the rename function. It's a little helper function, dplyr, and then you can rename those features here. Okay, so you do that. Yeah, so you cannot see this here, but let's have a look at the next one. The next thing is that we do a little bit of cleaning the data. Sorry?
I would have expected the syntax to be exactly reversed, in that I would expect if I'm going to rename lowercase id to uppercase id, I'd have lowercase id first is equal to uppercase. And they're doing a syntax exactly in reverse of what I would have.
Well, is it like that? Is it? Oh yeah. Well, this is the way you do it is you say it is the new one you want to create is ID in capital letters, and you assign ID the old one, the old version of the feature, which is the small ID.
Yeah, I think in pandas it's just the other way around.
Yeah, I know what you mean. It would be the other way around, yeah. But I mean, this is R.
Everything's the other way around.
Yeah, I will use some things a little different.
7 years ago, I tried to play with it and I lost.
Yeah, it's actually, I think when you start out using R, it's way easier than if you are already like working with Python and then trying to use R.
Can the arrow function work here? Like the arrow, you know, R can also accept the reverse arrow pointing back. Can we say ID? Can we use the arrows here?
You mean this here?
Yeah, something like this. Can we do that? Also ID, back arrow, then ID?
Yes, you can also do it like, so you can also rename it with the classic way. So this is the how you would do it with dplyr. You can also, there are also various other ways of doing that in R.
Okay.
Yeah. So this is the special, dplyr is using this kind of grammar of graphics and typing thing, and that's a unique thing to R, I would say. And
because I was reading something, and there was a similarity between R and APL in handling data. So and so on the low level, the syntax, sometimes they said you can just do away with the call to sign and then use the arrow sometimes. I was thinking, does it really matter? Can it break something, or it's not just the right way to do it?
Yeah, well, the thing is that there are various different interfaces on how to work with data. So one other very popular package for working with tabular data is the data table package.
Okay.
I personally did not use it that much, but it's a very, very, very different syntax of working with data. Much more, I think, much more than you would do it with pandas. Much more like you would with pandas.
Okay, thank you.
Yeah. Okay, so and then. So in this part, I'm going to clean up a little bit, and so everything which is stored in this data frame is at the moment stored as character, and so to change or to mutate a feature, we can use the mutate each function, and so we parse in the whole data frame, listings data frame, and then he is searching for. So here is. Replacing when it finds a $, replacing it and parsing as a numeric, so as a number, and it only does it when the feature contains the word price. So when the name of the column contains the word price, it is replacing the $sign inside of this feature with nothing, and then parsing it as numeric. So of course you have to have a look into the data to see how it is formatted, and then you can create this kind of piping. And then you take all this and do it again for the date. So you find so in this case, it's explicitly parsed in which features are dates, and then it's parsing it as date. But again,
so mutate each is basically an update of the column.
Yeah.
Okay.
But I just saw when I tried it an hour ago that mutate each is deprecated, and I think mutate at would be the replacement for mutate each. But that's that's not important now. But one thing is that it's, again, when you read through that, it is pretty verbose. You can, even if you do not know R, kind of read what's going on here. At least I think that it's like that. Okay, let's do that. As you can see, mutate each is deprecated.
Yeah.
Okay, so now we have a data set that is cleaned up at least a little bit, and then there is a categorical feature in this data set which is called neighborhood group. So there are different neighborhoods in this data set for each accommodation. And when we look at the unique values of these categorical variables, we will see that there are some 12 or 13 different neighborhoods in Berlin, and where we can find accommodations from our Airbnb. And an interesting question would be, what is the average price for each neighborhood, right? So we can take our listings, so the complete data frame, and then we use the group by function, which groups this this data, so makes a group and a different data frame for each of those neighborhoods we can see here. And then the summarize function is applied to each of those groups. So we calculate the average price. We also calculate the median price, because you can imagine that sometimes there are single, very expensive accommodations, and the mean is kind of skewed then. And then what we also want to see is the number of listings for each group. So how many accommodations are in each group. And that's important because each of the functions you apply after grouping the data set by a specific categorical variable, the summarize function is applied to each of those groups. And then we arrange the resulting summary in descending order. So, and when we plot this or print this, we will see, okay, Charlottenburg seems to be the most expensive one, but that's the average. So what we can see here is we have a pretty high average here, but the median is much lower. And that means that there are probably some single very expensive accommodations here. And yeah, so that's kind of a very easy way. So once you get used to this kind of piping and the way you write this pipeline, it's very easy to create this kind of summarizing table. Okay, and another question could be, what is the mean and maximum weekly discount per neighborhood? Because when you rent an accommodation for a whole week, you can get a discount on Airbnb. And so we first take the whole listing, so the complete table, and then we say mutate. Mutate is to create new features, so for feature engineering. And we define the new one as week price per day. And we take the weekly price and divide it by 7, of course. And then the next feature we create is the weekly discount. And this is the price, so the normal price minus the week price per day. So to get the discount we get when we rent for the whole week. And then again, we group it by neighborhood, just like we did in the previous one. And then we summarize it by calculating the mean and the maximum discount here. Let's see. Yeah. So as you can see, there are some differences. So again, in Charlottenburg, it's pretty high, so you can get a pretty high discount. And in Marzahn, I don't know, someone here from Berlin maybe. So Marzahn is probably not the best neighborhood, I think.
It's good for a discount, yeah.
Yeah, and so it's already cheap and you don't get a big discount, I think. I don't know, but yeah. Well, you can see that with this kind of code, you can very quickly create those kinds of insights into the data. And also, you can use it with Gplot, which is I think the most famous plotting library for R. And you can directly pipe those data you created in those data pipes into a Gplot object. I'll not go into the details of Gplot now, that would be a whole different topic. But what we want to look here at is if the price is higher of the accommodation when the reviews are better. And so the first thing what we do is filtering by, what is it? Yeah, okay, we say that the number of reviews has to be bigger than 10, of course, to have a good mean value. And then we push it into this Gplot object. It's basically just a scatter plot. Let's do that. Awesome. What you can see here is the scatter plot. And actually, you can also use PlotLight, which has for R a function that's called ggplotlight. And you can paste in the exact same code here into the ggplotlight function and create an interactive plot. So it's the PlotLight package for R. Looks the same, but you have kind of this interactive features. You can zoom, for example. Yeah. So that's pretty nice. It's really nice for quickly having insights into the data. I think since it's pretty late now, I'll not go on. But as you can see, you can do a lot of stuff. And one cool thing you can do also is use the leaflet package also with piping. Leaflet is for plotting geographical data. And when I do this, so this is basically telling you where the superhosts are. Superhosts, you can get superhosts on Airbnb if you are very good. And when you zoom at this, you can do cool stuff like this and zoom into the different parts of Berlin and see where the superhosts are. So when you want to, when you are often in Berlin and want to check out where the good hosts are, you can use this kind of visualization. Okay, So I'll stop now with dplyr.
Kai?
Yeah.
How did you scrape the data in the first place? Did I miss that part?
Yeah, someone else scraped it for me. So let me show that. No, there it is. Well, this Zoom controls are a little bit annoying here. Okay, so I think when you search Airbnb data, you will probably find that. Gets it there. Yeah, it's inside Airbnb. It's someone who wrote a scraping tool for data, and you can, yeah, when you search, for example, Berlin, yeah, you will find Berlin. And this is what I downloaded, really just like 40 minutes ago. No, 1 hour ago. But this is the listings I just loaded here. Okay. So someone else did all the hard scraping work.
Yeah.
But that's pretty cool. They have pretty cool data, for sure. Okay, so Christian,
yeah,
do you want to jump in?
Let's continue with some plotting. Yeah, I'll try to grab the screen. I failed with that with the last ML meeting, but I get better at Zoom. Zack. Are you seeing the slides or are you seeing something else?
I can see the slides.
Okay.
It's working perfectly.
Okay, cool. So it's not really a talk or anything. It's just kind of a summary because I was revisiting how to plot in 2018 in Python, and there was a lot of developments going on. And I just mentioned a couple of the packages, and maybe we can discuss what people are actually using. I would be curious which are actually used day to day. So obviously there's like loads of different styles or features you can plot. There's this famous one where you can basically pick the most appropriate one for your task, like if you want to do comparison, which is most effective. Just wanted to start with that, but actually what I wanted to show is this one here. It's basically someone made choosing a Python visualization tool flowchart, but it's lacking some of the stuff actually that that is available now. One thing I want to highlight or mention, because Kai was also mentioning it, is that there's now a pretty decent package called Plot9 in Python, and I don't really see a lot of people using it, and that's kind of a one-to-one API clone of Gplot for Python, and it, at least for the stuff I used, it works really good and much better than the previous clone Gplot2 for Python or whatever that was called. That was only 80% there. So that's really good, but I don't see much tutorials or mentions of that. So I was just curious, maybe we can discuss later if someone is using that. Then obviously matplotlib as kind of the granddaddy of all the plotting. The pandas included one, which is just relaying to matplotlib. Then there's a Seaborn that's also just using matplotlib, but giving it a nicer, more focused statistical kind of thing. And then there's all these new dynamic interactive ones. And to be honest, I do most of my plotting still in matplotlib, at least if I want to customize stuff. And once you get over that, there's like two APIs, like the procedural one and the object-oriented one, which makes learning it really hard because there's like two different styles of using it. It's still okay. I still find it okay, and they just went to version 3. I don't really know what the big difference is. I think it's Python 3 only now. But the big jump was matplotlib 2, I think. And that feature-wise shouldn't be too far off. And if people don't know that, I mean, basically, yeah, it's kind of wordy, right? You have to specify quite a bit, but I don't know. I often fall back to it still, and you can do some pretty complex stuff with it too. I mean, the next one, I'm not going into the details here. The next one is just a slide from a recent paper that I did with our group. And you can do some pretty nifty, like multi-panel customized stuff, but you need to invest some some code into it. So I think this one was roughly like 300 lines of code, I guess.
Cool.
But you can kind of customize all levels and panels and do stuff, but it's kind of handcrafting, right?
And how long it took you to actually create this masterpiece?
Say again?
How long did it take to write the code? Yeah.
I was reusing some stuff, but yeah, probably, to be fair, a couple, like 1-2 weeks maybe. But it's kind of iterative, right? So you when it's for the paper, you kind of finish it up and make it nicer, and you can nerd out. But yeah, as I said, I still use it. Something that I always wanted to use really more is Seaborn. Because they give you like a really focused interface. It's like super concise, but it's, I don't know, for me it was always pretty limited. Like you can do like a couple of plots, and if you want more, then you're kind of out of luck. I mean, they have dedicated plots. They look really good. If you just need this for exploration, for instance, you can get some really good plots in like 2 lines of code. So it's really nice, and they have really decent color defaults. Something really bad for some other packages. You get some pretty good default plotting going, but I don't know. I wanted to use it for more fast, like gt2plot style plotting, and then I was always like running into a wall with the interface. Like there's only a couple of plots, and if you want to have more, then I always struggled. I don't know if that's now different. I've seen that they increased the version number. But for a couple of, like if you're after some of these plots, like the pairwise plot or some other, then you get some really good ones. And I see a lot of people just importing the library for these couple of plots and then doing other stuff with other libraries. I don't know. My current favorite is now this Plot9. As I said, that's pretty much a clone of Gplot. Looks the same, so it looks a bit un-Pythonic, to be honest. But it works pretty well. I mean, you have the same AES for the aesthetics. You chain the layers of how you construct your graph, and you get pretty much one-to-one the same output. So it's, I mean, I've seen that some of the more advanced stuff is not there, like triangular plots, which you can get with add-on packages for Gplot, or a couple of the maps features. But for anything default, it's pretty decent, and I kind of like it. And for people who don't really know that, I mean, that's the grammar of graphics is basically that you separate data, aesthetics, geometries, facets, statistics, coordinates, and the theme. So you kind of compose all the aspects of a graph. And to be honest, that's the only thing I had that brought me back to R. Was always the plotting. That whenever I need decent plots, I always went back to R, and that feels like I can kind of maybe get out of there. I mean, yeah, R is fine, but it's just, yeah, if everything else is done in Python, it feels a bit odd to just for the plotting move over. But I mean, you can get the XKCD theme, you can get everything, and that's just illustrating it, right? For people who don't know the Gplot kind of thing. You can have the facets, which are super useful for me. Oh, that's like the feature I use the most, or I like the most, I guess, to just pull out your data. You can apply statistical transformations. You can specify all the aesthetics and make your detail as freaky as you want. And as you see with the code, it looks like, for people who are familiar, it's almost like our Gplot code. It's a pretty good interface.
Yeah, that system is really thought out, very, very good. All this, this grammar of graphic things. So
yeah, it's really cool.
When you really learn how that works, it's plotting on steroids.
We actually use that for teaching. I'm doing data analysis at university, and it's a bit odd for the students in the beginning, but once they kind of get it, it's super cool.
Yeah.
And
so, sorry,
yeah.
Go ahead. I just had a question. So do you use this for creating high polished kind of presentation graphics, or do you actually use this when you're doing investigations? I tend to use really dirty, just pandas defaults, just to get a visual into various different distributions in flight.
Yeah, probably like the quick and dirty, like pandas plot, just to see what's in there. Yeah, and I mean, for the ggplots, they can be quite concise too. So I often just also use the ggplot because you the plot9 thingy, because you basically just need the first kind of data assignment row and then like one or two of them. You don't always need like 4 or 5 lines of code.
Okay, so you're suggesting that it is worthwhile to invest in understanding this for in-flight analysis.
Yeah, I think so. I mean, it's pretty straightforward. I mean, you pick your data with the ggplot. You say which columns contain your data. That's the aesthetics, like which should define the graph. And then you define which geom, so basically what representation, in this case, a scatter plot, so it's geom point. Then I want a linear smoothing over the top with a stat smooth. And then I want to pull the data apart on the variable gear, so that's defining the panels. And then I plug a theme over it, which you don't need, obviously.
And is it compatible with pandas, or is there a panda kind of linkage where you can?
I mean, it's not fused to pandas, but you just chug in a pandas data frame. Okay. So the empty cars is just a pandas data frame.
Okay.
And the individual bits are basically columns of the data frame that define certain aspects of the plot.
So for me, R was the first language that for data analysis, and I still think that R is the best tool, at least when you have a little experience, the best tool to kind of interactively explore data, just like I showed the Airbnb data, because, well, of course, when you have done like 15 years of Python and only a few months of R, you will be much faster in Python. But this kind of the way you interact with the data and you create this kind of plots. So once you really get used to it, you can be very, very fast in kind of interactively explore data.
Yeah. Speaking of the interactive ones, that's the last slide actually. I was curious what are people are using, because I don't really use them. I looked at Holub, which is like an annotated data interface, which looks like super cool. But since I kind of stayed away from Jupyter for a long time, I never really used these interactive ones very much. So, but recently I had a look again. So it's kind of cool because you can attach sliders to your data. I think it's similar to interactive Plotly stuff, but maybe a bit more involved there. And you can get some really advanced stuff. And also they have like an extension for geographic data visualization. So it looks kind of cool, but I'm not sure like if people are using this stuff. Same for bokeh. That's probably something in between, because it's quite often used in the Jupyter notebooks as well. And I don't know, Kai, you're using Plotly, right?
Yeah, well, for the software we are developing, I'm not the one who is creating the front-end stuff, but actually we did this workflow where I created plots in R with ggplot and then used ggplotline, and then you can kind of look at the JavaScript code and use it.
Okay. Yeah, because I was wondering what the big incentive is, but if you want to basically go web or like web app, then it's probably really.
I mean, what R has is Shiny, and that's really a good tool when you want to create kind of a data exploration tools or any kind of data working tool for small groups. So we use that for creating data exploration tools for specific use cases for some, let's say, 20 people. And for that use case, that's very cool. But when you want to create scalable web applications, I don't think that R is feasible.
Yeah, there's something also that I had a very brief look at that's called Dash. That's also from Plotly, and they basically provide you with a dedicated Flask environment. I never really used it in production. I planned on using that for the course, for the deep learning one, but I went with the old school Flask and now Plotly.
But there's pretty much stuff going on at the moment. So I think the future is going to bring very, very good frameworks to easily create exploration.
Yeah, it's really cool because like 4 or 5 years ago, I was basically manually doing everything with Matplotlib out of necessity, really.
Okay, so
that's it for me.
Sorry?
That's it for my slides.
Okay. Yeah, thank you, Tristan. I've seen in the chat that some people are asking to do more specific meetups on like plotting, or here someone says, can we have a session on plots only? And I also wanted to show you how I use Docker. So we are now almost on top of the hour. So I can give you a real quick sneak peek on that. And maybe those kind of special meetups, we can repeat that in the future and talk about all this interesting stuff.
Yeah, I mean, if people are interested, I mean, I could certainly, probably not very soon, but in the midterm, do like, or we together could do like a Plot9 Gplot grammar of graphics kind of thing. For instance, for people that are not used to that, we can compare how compatible that is.
Yeah.
Yeah.
Okay, I'll just give a quick sneak peek on how I use Docker. So let's see, just one slide.
Thank you, sir.
Docker is, probably most of you know what virtualization is. So a virtual machine that is created on your host system, which is a completely encapsulated system. It does not share resources between other machines and the host system. Also, it's a completely emulated computer you have there. And of course, you have a pretty big overhead when you do it like that, especially when you want to use more different environments in parallel. And it's not so on your classic workstation setup. It's not really suited to use for data science environments. And then there are containers, which is basically just an isolation of an environment. So you can use the whole resources of your host system, and you can share those resources between containers. So when one container is using all the CPU power of one host, the next container is going to struggle. But when you are only using one container, you really use this resource. So it's pretty much, or very little or almost no overhead you are creating with those containers. And that's actually pretty perfect for data science environments. And since NVIDIA created NVIDIA Docker, an NVIDIA Docker environment where you can pass through GPUs into this containers, you can also use that for the deep learning environments. That's actually what I do for Fast.AI, for example. I also do it for my R environments, but I think probably a lot of you are also doing the Fast.AI courses, and I have this Dockerfile, which is pretty easy. Actually, this version of the Dockerfile is modified or almost mostly created by a TWiML community member. I don't remember his name, but he adapted this to the new version of the library. And it's basically just loading, in this case, a PyTorch image from NVIDIA, which is pre-installed with all the PyTorch stuff you need. And then he's installing all the Fast.AI stuff. Yeah, so I'll not go into detail on that. Maybe next time when we do a special on that. And
by the way, it's not working. Sorry to interrupt, but it requires the latest PyTorch version. I was playing a couple of days ago with this Docker image.
Yeah, this one is working actually, because this one is installing the new PyTorch version inside of the container. So this one is working. So did you?
I was following exactly your rules from your repo on GitHub.
Yeah,
that wasn't.
Yeah, that's outdated. Yeah, you're right. That's outdated. But that's a new version. So when you write me on Slack, I can give you the new version, and this one is working. Actually.
Okay. Well, I kind of fixed it myself, but
okay,
thanks.
awesome. Okay. So this Dockerfile is creating what's called an image, and it's basically a blueprint for creating those containers. And here in this case, this is not my MacBook where I'm on. This is the workstation on my which is standing in my office. No, I'm not connected anymore, I think. Oh, wait a second. So this map function is a little helper function that I created. I'm building an SSH tunnel to my workstation in the office, and I'm also mapping the port 8787 for the Jupyter notebook onto my MacBook. And when I start this container, which is, I'm using an alias for this. So this is the command I use to start this this image or a container built on this image here. And when I do that, it's starting up. You can see it's the NVIDIA PyTorch container here. And then it's starting the notebook. And then when I go to my browser, oh, no, that's not my browser. Where is it? Did I close it? Okay. Wait a second. And type in localhost 8787. Then I can access this Jupyter instance on my workstation. And that's pretty cool because when you are always installing this different frameworks and all the CUDA stuff and the Culian and stuff, which for different settings, you need different versions of each of them, then I really often destroy things and need to reinstall everything. And that's really a good way to kind of isolate all of this. Yeah, so maybe we can talk about this in detail on a future special session.
So I'd like to make a couple of comments. So everything I use on my machines here, I have two very powerful machines down here, is built on top of your Dockerfile. So thank you very much for your support. I've extensively extended them and they are working amazingly well. So on one of my machines, I have Ubuntu 18.04 with a Titan V, so I can run the latest machine learning stuff on that one. And then I have another machine which is running an older GPU specifically because there's versions of various different libraries out there that will not actually run on the latest series GPUs. They're just incompatible. I just want to make one very quick point, which is I studied extensively looking for other Docker images that would work with the NVIDIA GPU images, and the only one I found that actually works is yours, Kai. Yeah. And the others are very misleading because they take a very, very different path to build up the various different layers in the Docker, and they're very incompatible. So yeah, this has been a revelation for us. So thank you. That's all.
Yeah, you're welcome. So there's one, so I'm using this NVIDIA Docker containers that are provided by, they have their own registry for that. And you have to register for this or sign up for this registry, and you're not allowed to redistribute them. You can use them for whatever you want to use them, but you're not allowed to share them. So I'm not able to create images and load them to Docker Hub, for example, to provide it to others. But the good thing about this is that all this installation stuff, all the nitty-gritty stuff you have to do to get this running is done by the NVIDIA folks. And I mean, who else could do that so good? Yeah. And the actually the NVIDIA containers that are used here are optimized for the for this graphics card, for the new what did you say? What was it called? The new one?
There's more newer ones. I've got a Tesla Titan V.
Yeah, the Titan V. I think they are optimized for this.
Yeah, oh, it's blazing. It's 40 times faster than a 16-thread top-of-the-line 4 gigahertz CPU.
Yeah. Kai, can you actually deploy that stuff on Google Cloud?
Yeah, like, you can use it for any use case you want to use it. But you are not allowed to redistribute it because it contains code from them. So any kind of use case where you want to deploy your own stuff, you can use that for free, but you cannot use them to images and redistribute them.
Okay,
That's,
interesting.
well, look it up. That's at least what I understood.
Cool.
Kai, I have a question about NVIDIA's Docker containers and Docker original one. So NVIDIA created their own Docker implementation because they needed to have PCI Express kind of path through to interact with the GPUs directly. But it seems that the original Docker now supports that functionality as well. Is this correct?
I don't know what's exactly going on there, but what you have to do is you have to install a NVIDIA runtime environment on top of the original Docker daemon. That's what you have to do.
Got it. So basically, it's kind of NVIDIA's Docker, but embedded into original Docker, and the probably vanilla Docker will not work.
Their Docker containers are really just normal Docker containers. I think they're using Ubuntu 16.04, I think, and but all this installation stuff of cuDNN and all this other stuff, and all the optimizations they do for these containers, so they are specifically geared towards deploying stuff. That's all their proprietary knowledge, and they don't want you to distribute it to others. So you can use them for whatever you want, but you can't distribute them.
That is kind of weird, though. I think NVIDIA will benefit significantly by releasing and letting others use it.
I think so too. Yeah. They have in their normal Docker Hub repository, which is freely available. They have also CUDA images. I actually did not try them, and I want to try them, but I don't know how good they were compared to those proprietary NVIDIA containers. So, and I'm actually working. I just started a few days ago on a tool, on a command line interface tool to kind of manage, install, run, and stop those kinds of data science environments, because there are some specific things you want to have. You want to have access to your code on your local machine, and you want to have access to the data on your local machine, and also you do not want to lose configuration, for example, when you start and stop these kinds of containers. And I don't know how long it takes me to bring up a version that can be used, but I started working on a command line tool to work with those containers, and I will announce it once I have a stable.
So how do you want to implement it? Will it be just mounted folder, external folder, where you will have configuration files and data sets, stuff like that?
Yeah, so I'm going to support RStudio and Python, Jupyter notebooks, and I'm trying to. So the more complex thing is to try to find out how to work with the configuration files. For RStudio, that's pretty easy. There's just one configuration file that you have to mount into the image, and also for code and data, I just you can specify two paths from your local machine, and then this is going to be mounted into the container. There are some issues with the permissions. So the best thing I figured out is to inside the container have a user which has exactly the same UID and permission level like you have on your machine, so that you don't create data in your folders that you can't access later on, and all that kind of stuff. So that's a little bit some stuff to figure out.
So I've already figured that out, and you are correct. That's what you need to do.
Yeah.
So I have Windows and two variants of Ubuntu all working out of a common folder, and it all works with all the permissions and everything. So if you need help with that, let me know.
Yeah, awesome. Okay.
Has anyone dabbled in the mighty and scary Docker Compose?
Yeah, actually, I use it for work.
I still have not found a good on-ramp to that, so perhaps we should have a separate group working on Docker Compose, because it's very powerful. You can have multiple Docker images all talking to each other, which is mind-blowing.
it's basically just creating. You can start up several containers at the same time. You can specify the parameters for the startup, like ports you want to mount and volumes you want to mount into the image, environment variables in this Docker Compose YAML file, and then also a virtual network is created around those containers so that you can exchange data between them. I think that's interesting when you want to do kind of this microservice architecture for products where you have several APIs communicating with each other.
Can we do the same thing with Kubernetes instead?
That's exactly. Is there a transition path from Docker Compose to Kubernetes? And I think the answer is yes.
Yeah, I think so. So I just use Docker Compose so far, but I think Docker Compose is really just to do that on your local machine, and Kubernetes is more for the deployment part, right?
Makes sense.
Yeah, I haven't touched on that yet.
I think, Kai, you have to do a session on Docker.
So there are several sessions we can do in this meetup. Yeah. So next time Shirin is going to present, and sometime in the future Christian is going to present something too, a full-fledged paper. And then we can, from time to time, we can do this kind of sessions where we talk about those kind of stuff. Awesome.
Cool.
So nice to meet you again. And the next meetup is already scheduled for December the 4th, I think. But it's going to be announced. And then we'll hear the model interpretability talk. Awesome. So have a good day, good evening.
Goodbye.
Thanks very much.
Thank you.
Yeah, that was fun. Thank you.
Bye.